Good evening, Professor. This is my personal timetable. So, I'm also doing the new work with the new antibody and antigen. So, I'm stuck on that. So, the first one is already going well, the coronavirus paper. So, we have already sent the chemical samples to the Khan's nanofab lab, and today that instrument guy measure our sample, and in the maybe tomorrow before lunch they delivered our results, so we just use that results, use that images to implement in the manuscript, and soon we will deliver you the final draft of this paper before 15th of December. And task 2 is the RF review paper. We have already removed something, the plagiarized things. And also, as you suggested that to Yachna that send the appeal letter. So yeah, so it's the appeal letter we have already sent. So waiting for the comment, waiting for the reply. And the third one is the aptamer biosensor research. So we have already looking for, like, on this week, me and Rinseng and Dongmin will go start from tomorrow this aptamer biosensor research, and the PSA is already on the way. So um, today I just finished the EDC part, so the result is quite good. And tomorrow I just use the antibody and antigen to immobilize on the surface and then check the capacitance, and hopefully I will deliver you the result in the last in the on Friday. I will give you the results of this research. And the task 5 is AAO Biosensor research. Sir, unfortunately, I have to say that the Ag particle is not dissociate after the using of sonicator, because of the protein, the protein itself having a self temperature, and a sonicator maximum is the room temperature is okay, but after the room temperature we didn't use that sonicator, because if we use it then the protein dissociate, and protein is ruptured at the after the exceed from the room temperature. So we just do the room temperature, so we didn't get any positive response, positive results after using the sonicator. So we also tackle this, and simultaneously also booking the chemical of MUA that is already used in some papers. So looking forward to wait for the MUA, and simultaneously also looking for the best immobilization method to treat with the AO and check the LSPR. So this is the new antibody and antigen. So we already got it, and we already started this research as well. So as per my understanding, this antibody antigen is quite good, better than the previous one. And in this week, I'll definitely send you the results after the using of this antibody antigen. So this is my PSA biosensor experimental recipe. So we follow this recipe. We are using D5 chip, but today I also use the D4 to check which chip is good for us. I know it's already D5 is good, but for the if I consider the space, like the how much uh, actively space, so D4 is also having a less space as compared to D5. So simultaneously I use both, and today I just checked the EDC part, so I found that the D5 is better than the D4. So I moved to the D5 and to check with the antibody antigen. So we follow this recipe, and in this week I just finish up to EDC, and then tomorrow I will put the AB antibody and antigen, and we fix it, and send you the result as soon as possible. So this is the AAO Biosensor research work. So we already stuck here and to check like which one is good for us. So to get the better results. So we already have the literature survey and to check how the immobilization process. So after sonicator, we didn't get any positive response. So because we did not exceed the temperature of sonicator because due to having the protein and the protein itself having the some temperature. So that's why we didn't exceed the temperature. So we just put only for half an hour and to check that the Ag particle does not have dissociated because in the LSPR measurement we got the same results, and even the after sonicator sample getting the bad but with the worst result better than the poor than the previous one. So we didn't use the it's not worth to use this sonicator, and also simultaneously looking for the immobilization process, how to immobilize, because we did the spin coating, we did drop casting. That was not quite good for us for this research. So we move and we have to check it out which one is good, and hopefully in this week we'll tackle this and to get the solution. So this is the for the metasurface research recipe for the AAO, and also we just do the two kind of plants. One is using the washing with the PBS at each step, and the second one is the without washing with the each step PBS. And so this is the two different kind of okay. So this one, and for MUA, this is the MUA chemical. The use is already in this paper. I already put here the DOI for this paper. So we found that the MUA is better than the other things. So we moved to the MUA, and the Bruce already ordered this. So it's preparing already for SEM. It's hydrophilic AO surface. I already explained to you before that what we got the issue for this one because of the using of the graphene oxide. Graphene oxide flakes act like a barrier between the AO and NAG protein. So that's why all the AG content are just simply immobilized on the AO surface, and it does not penetrate into the nanopores area. So because of the graphene oxide, it might be getting problem on the surface. But if we use MUA, that is already purchased, is on the way, and we will get this chemical as early as possible. So if we use MUAs, it might be getting more good results as compared to the graphene oxide. And simultaneously also we found that there is a gap between the glass and the AO, having some air or some vacuum there. So because of that, it's there be maybe I think 45 nanometer gap. It's near about 80 nanometer gap between the AO and the glass surface. So it doesn't matter what we got here, the gapping, but the matter is the graphene oxide is not good for our AO research. So that's why we moved to the MUA, and hopefully we will get the better result after using the MUA. And as we know that there is a gap between the AO and the glass. So if we put Ag protein, is all the Ag protein it just penetrate to the pores and get submerged onto the glass. So it's a gapping filled by the content whatever we put, but here we put first Ag protein, so that's why the Ag protein is just in between the AO and the glass. And then we put the EDC, so it's quite a getting a sandwich kind of a structure, sandwich kind of method, and the arrangements. So this maybe the gap will be full out, and in the case of because We put here 2 microliter or like 4 microliter Ag protein. So now we have to um, decrease the content, decrease the volume of the solution. So if we decrease the solution, then we decrease the surface, like the layer between the A and Ag glass. So that might be getting more good than this one. So we found that the structure after spin coating, the spin coating structure is quite good, better than the drop casting, but the after spin coating we found that the LSPR measurement there is not a good results, because I don't know what was the reason behind this, but these two method is not good for AO. So we already have searched so many papers to how they immobilize their content or their samples onto the surface. So we already think about it, and Bruce will also find this solution. So that's we are more concerning about this how to immobilize. So we are already thinking about so much, like we did spin coating, we did drop casting, but not getting the best result, not the good results if when we do the LSPR. So I don't know, the problem is in AO membrane, or like the problem is been between the samples, or like what we have to do. So sir, I request you to please guide us to like what we do now, because we are stuck in here, and we didn't find this way to get out and to move to the better results. So please guide us, and we are very grateful to get the solution from your side. Thank you, sir.